Great. So welcome everyone to another session of the Future of Work. My name's Chris and I'll be hosting today's session. And we have the Barga or Dave Day as our guest today, who I'll introduce in a little bit. Before we start, just a couple of logistics or how we're going to organize it. We like to keep these sessions social. So feel free to turn on your camera so we can see each other. And we're happy to have you join in the conversation. Make sure to mute your microphone. By now, everyone's used to online etiquette, but just in case. Today's conversation is part of a series which is partially funded by the National Science Foundation and is being organized by Andrew Kuhn, Orit Scheer, Linda Boyle, John Lee, Rafaela Sadoun, Manfred Shaligi, and today by me. If you have questions, I'll start the conversation with Dave in a bit, and we'll first talk with the two of us. If you have questions, put them in the chat. I'll keep an occasional eye on them on the chat. If it's a good question, I can ask it right away, or otherwise we'll save some time for later when you can ask your question yourself, which is our preferred format. So you get to get this feeling of interacting. With that, let me introduce De Barga or Dave from Eindhoven University of Technology, right here in the Netherlands. Dave, your background is in computer science and you completed that at Vanderbilt University in 2012. You spent some time in industry as a software engineer and you came to Eindhoven to work on your professional doctorate in engineering in user system interaction. And after that, you moved on to your PhD degree, which was awarded last December, and you passed cum laude, which is the highest honors in the Netherlands. So many congrats to you. That's well deserved, and a nice round off for that research. We will talk a lot more about the content of your work, so I won't give that away yet. But in a broad sense, you're interested in automated vehicles and how people perceive their safety, and also how they communicate that with other road users. So welcome, Dave. And to kick this conversation off, I was wondering if you could explain to us, why is it so important to focus on the communication of the car with other road users? Because if we're in the future, won't all these cars already talk to each other?
Yeah, that's a very good question, Chris. First of all, thank you for having me. It's a real pleasure to be here. Going back to your question, when we talk about the future of automated driving, it is indeed true that if we are looking at the far future, probably we are going to find ourselves at a point where we are surrounded by automated vehicles and there are no cars that are being driven by humans. And if that is the case, then indeed vehicle-to-vehicle communication will rule. And there is perhaps not so much of a need for communication with other road users, because the other road users are just other automated vehicles. But in the nascent phases of introduction of this new technology, when we are going to be sharing road space with other drivers, pedestrians, cyclists, it is rather critical that there is a confluence of good interaction and a good traffic flow can be propagated, which is one of the big reasons why we want to have automated vehicles in the first place. So that's when we run into this need for a good interaction. And why this is also a little bit tricky is that most of the times, from common sense, we approach interaction with other vehicles from the perspective or the assumption that there is a lot of explicit communication involved in traffic. So one of the things, the moment we start talking about automated vehicles, the first thing people arrive at is that, oh, we're going to miss eye contact. We normally, when we try to cross a road, we look at the car, we look at the driver, we want to see what they're up to, and if they are not, if we are not able to establish that kind of a two-way communication, then it's disaster. Communication breaks down, and then we need something to address that. And that's where this whole need for communication arises, and that's what my whole research is about, where I look at my whole research centers around what we conveniently call the eHMI, which is a short for external human-machine interface, which is a device, let's say, for a car, an automated car, to communicate with other road users. So yeah, instead of rambling on, I'll stop there.
Well, I mean,
Yeah,
we're hearing all kinds of good stuff, so I was purposely not interrupting you because I was enjoying the content. So I think part of your work shows you introduced it as it's an assumption that we look at each other and see whether it is. So maybe at some point we'll touch on whether that assumption is true, but I won't give the clue away yet. Maybe I did. But I'd like to carry on by talking about these eHMIs, or external human-machine interfaces. So you looked at differences between very implicit and very explicit HMIs. So what is their difference, and is there sort of a preference for one over the other?
Yeah, so when we look at the very basics of the definition of communication, by implicit communication, we often end up meaning something that a message is communicated without explicitly, well, I'm using the term implicit and explicit in the definition, that's not helpful, but something is being communicated without there being an express purpose behind the communication. I am just doing my own business, and then my mood or my intention is being communicated as a consequence of my behavior. That's what we mean by implicit communication. However, when it comes to cars, when people mention modes of communication such as seeking eye contact or looking for gestures, looking inside the vehicle, like has the driver seen me, and has he or she given me an explicit indicator or of whether or not it's safe for me to cross. That's what we mean by explicit communication. Now, there is a nuanced difference here. So when it comes to cars, the implicit communication is often things like the motion pattern, the kinematics of the car. When a car brakes, we often have this very intuitive understanding of what the car is going to do. Like when a car brakes, the front of it dips a little. These body language, for the lack of a better term, of a car is something they're very good at recognizing. And people, even with this implicit communication, people can game this a little bit, and we can emphasize implicit communication. And then the question has to be asked, that is an emphasized implicit communication after all an explicit communication? Because a person may choose to brake a little bit more, brake a bit harder, or brake a bit further up without approaching the pedestrian so closely. So then here we have this distinction between these kinds of communication. And what we ran a study to understand how this communication does happen in current situation with non-automated traffic. And we found that most of the time, people make a lot of the decision by just simply looking at the movement patterns and the kinematics of the car. Most of the time, there is not simply enough time to look inside the car. There is not even, the lighting conditions are sometimes not optimal. It's dark inside. The windshield can be reflective. The weather conditions, or even what happens at night, even, like, it's very, very hard to look at what the driver is doing until the car is really close by. So,
right.
and most of
you
the
still
time,
decide whether to cross the road or not, even though you can't watch through the windscreen of the car, right? So because otherwise you might wait forever.
Exactly.
On the roadside. Yeah.
And most of the time, the decision point happens way before when the car is even close enough to make that interpretation about the driver's alertness or situation awareness. So then, and one of the things that we also noticed was that a hesitation occurs only when there's a mismatch between what the car was expected to do based on the traffic law and what the car was actually doing. So if the pedestrian was at a zebra crossing, let's say, and then they noticed that they expected the car to slow down, but it still came at a pretty high speed, that was a mismatch. And that's when people said that, okay, I don't know what they're doing. I want to make sure it's safe for me to cross. And that's when there's this need for a little bit more explicit communication, let's say.
Right. I was also wondering, does that communication have to be human-like? So sometimes there are these conversations about, I think the Tesla car or cars that sort of have adaptive cruise control and some lane keeping ability, that you can't really tell whether they will change lanes or merge with your lane because they just do it differently than what we're used to. What's your experience in that front? Do these cars have to be do it the human way, or can they have their own language or implicit explicit communication form?
Yeah, this is a very good question, and unfortunately, I don't have a black and white answer to that. But
that is always good. Nuance is good.
Yeah, the challenge here is that well, we have seen from various studies that when people do not have an understanding of whether a car is automated, people are very happy to simply believe that this is just another car and they're interacting with it in a regular way. But the moment mode awareness is what we call it, the awareness of whether a car is operating in automated mode or not, the moment mode awareness sets in, that's when hesitation sets in because of the current mistrust in automation and things like hesitation to trust new technology, essentially is what it is. So also different studies have also shown that most of the times people are happy to treat a car, even if it's an automated car, as a regular car, as long as they don't know it. But if they do come to know about it later on, they feel betrayed. So they somehow want to know in advance that it is an automated car so that they can set the correct mental model in interacting with it. So this kind of leads back to the question of whether or not we need to show that the car is automated in the first place. And there are different schools of thought in this area. And when I started my PhD almost a little over 4 years ago, one of my supervisors, Marika Martens, maybe some of you know her, she's involved in the ISO steering committee, which is involved in a lot of the discussions of where this standard should go. And different car manufacturers had different opinions on whether a car should even tell that I'm driving in automated mode. And at the end of my PhD 4 years later, they're still having that same discussion. So at least it shows us that there's a lot to go around here. And another thing is that quite apart from this whole feeling of betrayal, if you will, that the car needs to show whether or not it's in automated mode, the question arises, how does the car show it? A quick fix could be something like a lamp that turns on when it is in automated mode. But this is another interesting nuance here. I was having this conversation with a colleague of mine yesterday. So we are talking mostly in terms of automated vehicles from a public transportation and passenger car or what we see around us in a road. However, there are also automated vehicles in other areas, such as in a mine. And those are situations which the interaction happens with professionals who are specifically trained on how to interact with such vehicles. And when they come to interacting with dual mode vehicles, which are capable of operating in both automated and non-automated mode, they don't have the system of when it is on, it is in automated, and when it's off, it is not automated, because how do you know that the lamp is not broken?
Right.
So there
might be gradations as well, right? That not everything is automated, but some functionality is automated and to a certain degree. So that's a nuanced problem. So it's good that you didn't give the black and white answer, because it's now clear where this is coming from.
Yeah.
I was wondering, in your abstract for today's talk, you wrote the question: are there any golden eggs for eHMI? So right, so are there certain factors that we definitely should consider that should be part of it? So given that it's your question, I'll just cheekily pose it to you. Are there any golden eggs in eHMI? So are there things that just work well?
Again, unfortunately, the one-word answer is no. But that's what makes this research interesting, doesn't it? So one of the challenges of this field is that, well, quite understanding that this is a rather new field and a lot of research we are just ramping up to doing a lot of work here. A lot of what we have done really deals with one-on-one communication, and like one car approaching with one pedestrian standing at the side of the road. And we are studying the fundamentals of human behavior and interaction. So which is fine from a cognitive psychology and engineering psychology point of view. However, that's not how reality is going to be. And the moment we introduce even the bare minimum of scalability, like not one, but two participants, two pedestrians, a lot of the current solutions already start to break down. So as of yet, there are no golden egg. We are far from reaching a golden egg, but then at least the research is progressing in the right direction, where we are introducing these concepts of scalability and also designed for people with accessibility needs. So this is well, it's a slow roll, but we are going to get there. And one of the things is also that, well, okay, I'll come back to that later. I think this is a sufficient answer for this question.
Yeah. There's lots of questions already in the chat, so that's good. Keep them coming in. Before we turn to those, I have one different angle that I would like to highlight and give the floor a little bit to you, which is about methodology, because I think some of the questions are about sort of the concept and what should we put in the technology. But one of the innovative bits of your research, I think, is that you thought about novel methodologies, novel ways of testing this, because we're testing some technology that we haven't seen before yet. We're testing some way of perception that is on the road. So you had this feeling of safety slider, which I thought was really cool. And I'd like you to explain a little bit, well, how did you come up with that design, and what does it do? So why is that an appropriate measurement there? Because that's quite an interesting methodological innovation, I think.
Yeah, thanks. That's a good question, Chris. We struggled a lot on how to define a metric on how do we measure interaction with an automated vehicle. Quite apart from the fact that we don't have an automated vehicle around us yet, we wanted to see if there was a way we can in real time measure how people's feeling of awareness, feeling of safety, and hesitation around around any car, let it be may be automated or not, changed. And therein, we wanted to also strike a balance between realism and safety, because one of the ways that interaction has been studied fairly frequently until this method was the moment of response time, perhaps, or the moment of when a pedestrian steps on the road in interacting with a car. And there were some challenges in the area in our understanding, which was that, one, it is a very
coarse measure.
Yeah, it's a coarse measure. It's not I'm looking for the words, but what I mean is that it's a measurement at one point in time. It's not a continuous measure. So the moment the pedestrian does step on the roads, the interaction is over. However, we needed to find a way in which we can actually continually in real time see how this trust or feeling of safety was changing. So there we needed to, we already realized that stepping on the road was not going to be a solution. So we wanted to have the pedestrian on the side of the road, and we looked for an input of some kind. And then the challenge, the discussion was between something like a push button or a slider. A push button as in you can keep it pressed as long as you feel safe to cross, and release it when you are don't feel safe anymore. And this has been a methodology that has been used by several research groups, but it is very clean in the sense that it really maps to your binary thinking process. The human mind, we either decide we want to cross or we don't want to cross. The decision to cross is a binary decision. However, we realized also that it lacks a certain measurement of the hesitation we feel, that maybe we want to cross, but we don't really know how much. And we wanted to give the pedestrians an opportunity to express that continuum. And that's where the whole idea of the slider came. And we did a pilot study where we even wanted to see, does this even translate, or are we just being crazy here? But then we did see that people responded that people were able to map their feeling of hesitation quite naturally with that slider method. And that's what we ended up using after all. So they could simply have the slider device as an input device in the hand and manipulate it in real time as the car came and indicate how it was a surrogate measure of trust, let's say, by their input being their feeling of safety.
Right, great. I think we have a lot of audience questions, and I want to make sure that we get to those questions, because that's the reward for showing up live, that you get to ask your question to Dave. Andrew, you've been keeping an eye on the chat, I believe. Who
Sure.
should we give the floor?
So I think we can just go in order they appeared. So maybe, is it Jingyu Li? Am I pronouncing your name correctly? So you were wondering about mode awareness and differences. So maybe you can just go ahead with that question, please.
Yeah, I also actually just spot your answers already, like the differences between kinematics and dynamics. I actually personally just have this, like terminology issue. I noticed this vehicle dynamics in the Klaus Bendler et al. Publication recently, like from eHMI to eHMIs, and where they use this term, but just giving simple examples like acceleration or deceleration. And I just wonder, is that all for vehicle dynamics? And I think I also Googled a bit. It's also another like interdiscipline, right? So another discipline or subject, basically. So I'm just confused. And as Dave, you just mentioned about this body language of the car. So I just wonder if you have a in-depth perspective on this terminology issue.
Oh, that's a good question, Jingy. Well, in general, from the human factors of HMI perspective, when we talk about vehicle kinematics, we are mostly talking about the movement of the car body based on the physics of the car, like as in like when the car brakes or accelerates, there is this nuanced pitching behavior, dipping of the front of the car, or the car seems to lunge forward under heavy acceleration. So that's what that's what typically has been used by the kinematics, by the definition of kinematics, but it's a little bit more abstract than the more mechanical definition of kinematics under in the vehicle dynamics point of view. But I also see that there are several other experts in the area in the audience who can also pitch in if there is something I'm missing. So yeah, and we can also pick this up later. But to answer your question in brief, I haven't looked so much into detail about the terminology part, except from what I just told you.
Yeah, thanks. Actually, I also have another relevant question, but yeah, maybe you can just chat later. And I think maybe I can still continue with the second question, the mode awareness. I also just checked the paper, the jungle paper, and I didn't find a lot about mode awareness. So basically my question is, how would you say, what is the difference of a mode awareness in eHMI between high automation level and full automation level, namely L4 and L5? And how to measure?
That is a very good question. So far, I'm not aware of much research in the area, and it's also, to be honest, it's also something that I haven't thought about myself. Just thinking out aloud myself, I don't know if there is a need for distinguishing between a highly automated and a fully automated car, because at the moment of automation, the responsibility does lie either completely with the car or with the driver. When you're talking about highly automated, I assume that you mean more level 4 cars, as opposed to level 5 being fully automated. And we're not talking about level 2 cars where a part of the responsibility does belong with the driver. And in that case, how I perceive mode awareness is a way to communicate with the external world. Whom does the responsibility of driving belong to at the moment? And even though it can change with time, and maybe the car doesn't know how to handle a certain edge case situation in traffic in a future point in time, at the present moment, the control belongs with the car, and that's what we are trying to show with the mode awareness indicator. So I think just thinking out aloud and reasoning out along the way, I don't see a need for distinction in this area, but maybe there's something I'm missing and we can talk about it more.
So Dave, are eHMIs really something for those higher levels of automation, because we need to know it's a car, it's not a person, be aware, it's a robot, it might miss stuff? Or is there a need for those eHMIs already in current commercially available systems, which are more at SAE level 2, where there's some form of automation? Or do the humans that are responsible, do the humans solve the problem for the car? So do the humans do the signaling and we can tell things by the humans?
Yeah, the shades of gray are just mind-boggling.
Okay,
but
maybe we'll park that. It sounds like there's a lot more. So,
there's a lot to process there. Yeah, indeed.
I think the next person on the queue was Andreas Riener, who said he has a long question, so he'll just say it. So we're all curious what the actual question is, Andreas.
So hi, good to see you all. Hi, Dave. So actually, it's a personal experience we recently had in one of our studies, and I think you have already touched the problem in parts also in previous questions or statements you made. So we conducted a study where we compared a four-way crossing with regular traffic lights and had a second condition with fully automated vehicles and no traffic lights at the crossing, but the cars communicating directly with visual signals. And we, as one of the questions, we asked participants about these concepts and which they like most and so on. And we found out that almost everybody liked the normal traffic lights and they do not want to have these individual signals. The problem is that they're used to the traffic lights and they don't know the other concept. They never have experienced it. And this is kind of this is a question maybe to all of us and all of you, because we often have this problem to compare a condition that people never have experienced before. So the question is how to deal with this problem, how to get feasible answers, or how to draw feasible conclusions from the results, because these concepts are rated worse, even we feel they're better. So this is a more general question to all of us.
Yeah, please feel free to pitch in your ideas as well, people in the audience. But I think we have discussed this problem several times in our lab, and the rather unsatisfactory answer we came to at the end was that, well, even traffic lights had to be introduced at some point, and people had to learn what red, yellow, and green meant. So, and now we are very comfortable with that code, and now we are a little bit resistant, let's say, to interpret other forms of code, which this is exactly something that we have seen in our study as well, because red, green, and yellow are so meaningful to us in the traffic context. We oftentimes an eHMI implementing these codes as well, like just a red light in the front or the green light in the front, they carry a significant meaning, but because of several legislative issues as well as human factors issues, we already know that's a bad idea, and that can never actually come to practice. However, the moment we expose a red-green eHMI to any other, the more acceptable eHMIs, they always score lower because of the way people are simply used to the codes. But I think it's also a matter of, yeah, it's a tricky situation. I don't think that simply because it's legislation, we should not. Yeah, it cannot be changed if there is a good argument for it. However, there are several good arguments for why. I'm sticking to a very specific example here of red green, but let's, for the sake of it, let's stick to it. So red and green are used in traffic light, which is a stationary infrastructure. So we always know the perspective to take when it comes to, when I see a red, it means I need to stop. But when it's mounted on a moving vehicle, red could mean that the vehicle is stopping as well, which is what we typically see when we see the brake lights but that makes sense because we are behind the car. But what if the red light is in front of the car? Does it still mean the car is stopping, or is it telling me to stop? So these can lead to like fatal misunderstandings in these cases, which is why it's not a good idea. Yeah, but Andreas, again, I don't have a good answer to this. It's a problem we are facing in our group as well.
So Dave, where's your hunch? I think the answer to my question will be we need all of it, but where do we need it most? So in these types of problems, is this a matter of that we don't have the right concepts, that we don't have conceptual theoretical understanding of some of the ways that how people process signals or what they expect or how they learn? Or is it a methodological issue that we need something like the slider, but something completely different, right, to study it, and we just don't have the method yet to understand it? Or is the solution in the design space that we haven't considered sufficient radical designs, and we should maybe explore it with design fiction? Or is it something else? Like, is there what? I think every one of those can contribute most likely, but where do you see the need most? Do we need sort of conceptual innovation, methodological, or sort of design proposals? Where or something else?
In my opinion, where this can lead to the maximum progress would be a conceptual innovation, because I try to stay optimistic, an optimist, and I want to believe that this is still a design challenge. This is not a fault of the idea in general. And yeah, here is one of the things that we always struggle with, this whole concept of this balance of the scalability issue. The moment the car as an eHMI starts to talk to multiple people, it suffers in terms of whom it is communicating to. So we lack a little bit of detail in the communication message. That is it meant for me specifically? And this, like, we are in the future of work discussion. So where do I see the future of eHMI? And I think the whole concept of eHMI mounted on the car, we will always run aground after a certain point. And this may be a little bit too fantastic and futuristic to think about, but one way that this can be addressed theoretically is by moving away from the car and moving to personal communication through nomadic devices. And again, that's why I say this is a bit too futuristic, but if we have all the different cars and the infrastructure being completely aware of what the situation is around it, and it's being communicated personally to an individual with their smart devices or through AR glasses, that whether it's safe for them to cross, that would be an ideal solution. And technically it is possible. However, there are concerns of how realistic this is.
But I like the fact that you're talking about futuristic, because so Sam has a question that I think is a little aimed at the future. So maybe, I don't know, Sam, if you would like to tell us, or we can certainly read it.
Yeah, thanks, Andrew. Hey guys, this is Sam. I was curious about, when you're talking about the mistrust between pedestrians and autonomous vehicles or vehicles in general, is it totally predicated on the fact that it's still in the public eye and unproven technology, and they just don't know whether, unlike a human, whether the car is going to respect the sanctity of life and their being? Or is there something else that predicates this mistrust? And if it's the former, where it's more like, it's just because I don't know whether the technology is proven or not, what could lead to a tipping point in terms of public perception that says that, oh, it's an autonomous car, it's going to be as safe or even more safer than a person driving the car on the street?
Yeah, that's a very good question, Sam. I think for the most part, this hesitation is coming from a mistrust of the technology, because people are simply not aware of what the limits of the technology are. So what is an automated vehicle? What is it capable of? And even different automated advanced driver assistance systems, the ADAS systems in different car manufacturers, they already, even though they are clubbed under this umbrella term of ADAS, they are already different in their capabilities. So, and this is just an example of a very weak form of automation, let's say. But when it goes to the future of high automation and full automation, we don't really have a good understanding of what automation means. So even there have been studies of people having been asked of, what do you think of an automated vehicle? What does an automated vehicle mean to you? What can it do? People have given very diverse range of answers. And so clearly I see a lack in knowledge, and therefore a need for educating the public of what this means, and there's also a need for standardization as well, because we can't have different OEMs have different definitions for what automation means for them. So once we have this kind of a general idea of these are the boundaries of what an automated vehicle can do, that's when we can hope to have a little bit more structured discussion of what it means to reduce this hesitation a little bit, because then it is more about knowing. The ethical conundrum is always going to be there, and that's the underlying foundation on which we build. And we right at this point, it's some the ethical questions are rather theoretical, but we are trying to get behind them and get beyond them even, and to understand how we can address the hesitation simply from the foundational question of, is it safe for me? I don't know if it answers your question, but yeah, we can follow up.
No, it does.
Later as well.
Thank you for that answer. Great answer and great talk as well. Thank you.
Thank you.
So with the foundational question, so Hattis had an interesting question, so maybe you can tell us.
Hi, Dave. You actually kind of answered some part of the questions that I addressed here. So what could you say about mental models of people towards automated vehicles? Do they see it simply as machines, or more like smart entities? So what's the general tendency right now?
Thanks, Hatija. Yeah, well, yeah, this also goes back to Chris's earlier question of whether people would want automated vehicles to behave as just regular cars, or whether they should have a boundary of how they should act. And this is, again, one of my supervisors always like to give this example that when planes fly, they don't flap their wings like birds. They have wings. We know they're machines. They fly. They accomplish the task, but they do it differently, and we're okay with it. And so I think when we are in this nascent phases of introducing this new technology, and when there is so much diversity in how people understand or perceive automated vehicles, maybe it might even be argued that for the sake of arriving at a common understanding and being on the same page, that some boundaries may be advisable. That this is how an automated car behaves. These are the boundaries of its capabilities, and there are certain situations maybe it can't handle. And then once we learn to live with those boundaries and learn to live where the capabilities end, then perhaps we can try to smudge the line a little bit, let's say, and then we can try to introduce a little bit of more human-like behavior in the future. However, I mean, this is not a clear-cut answer. Again, this is we are walking on the edge of a sword here, because also we noticed, as I mentioned earlier in the talk, that the moment people know that it was an automated car, but they thought it was a regular car, they do feel betrayed a little bit, and they don't like that. Yeah, I mean, this whole conversation, every time I have a question, I feel like, yeah, I don't know the answer, guys.
This is
yeah,
good.
but
you can build a career off of that when you don't have the answers yet, but you do have the good
we need
questions.
more research.
So I think you're in a good space, Dave. There's still more questions in the chat, but what I'd like to do is sort of work towards the closing of the formal part, and then for whoever is around, we can maybe do a couple of questions yet. But I was wondering, as maybe a shorter question towards the end, like, if we think about other domains, so for the future of work, for example, right? So are eHMIs really tied to the domain of mobility, or can it also be applied to other domains like the office, or is there a need for such like very explicit active communication, or can it be more passive? So the question in a nutshell, but it's maybe a tricky question, where do you see eHMIs in sort of other domains for the future of work?
It's another very interesting question, Chris. I actually have to think of the conversation I had earlier with you regarding eHMI in the office, in the workspace, where people would put on their headphones as a way to show "do not disturb me" or one headphone off, which means that okay, I am focusing, but I am ready, I'm available if needed. So yeah, there are subtle ways of communication all around us, and I think the eHMI, the context of eHMI that we explore in the automotive domain is a very specific one. eHMI, broadly speaking, eHMI is everywhere. But in the way that we look at it in the automotive context of communicating through lights, through these different modalities, and the challenges that we run into are very specific and not usually very, even in other contexts, they don't become very relevant. So we run into this very unique set of issues here, which do not even become relevant elsewhere, which is why I think that in this particular iteration, we cannot extend eHMI in the automotive context elsewhere. However, communication, the need for communication stays forever anyway, in whatever domain we go. So I think it's just a matter of keeping on looking.
Right. Thanks. I agree with you, and it's good. There's already enough questions in just that one domain, so I'm sure you'll come up with lots of concepts that we'll be able to transfer to other domains as well. Just to close, so thanks again, Dave, for today. Next week, the guest is Jennifer Goldbeck from the University of Maryland, who will talk about social media, the good, the bad, and the ugly, and how it matters for the future of work. And I have a warning for non-US people. The United States will switch to summertime, if I'm correct, this weekend. But here in Europe, we stay in the winter. Winter is still coming here. So make sure you are aware, because the time at which the conversation starts is 11 a.m. US time, but that will be 1 hour later compared to how it was today, if I am correct. So be aware of that, unless you also change your time zone. With that, maybe thanks again, Dave, and maybe we can stop the recording and there's room for informal conversation.